Hey guys, so today a couple of things we're going to talk about. We are going to delve into, again, this. I love to talk about this again and again because I really want to stress the importance of it. Good quality edge flow, nice efficient shape and form. That neatness helps out tremendously on a number of different levels. It not only communicates the fact that you understand and are able to use the tools very well. How many of you, incidentally, have ever seen a demo reel for a modeler? Have you guys ever seen one, a demo reel? You know what that is, right? The portfolio that you show in an effort to try to get work. One of the things you will notice about a demo reel for modeling is way more often than not, one of the things that the modeler does is show a turnaround of their model, and they show you the wireframe because they want to communicate, hey, not only can I hit shape and form, which is, of course, job one as a modeler, but look at how neat and clean I can do it, because that communicates professionalism and ability. Does that make sense? So we're always working on that neat and clean edge flow, if for no other reason to let other people see that how well we can model. However, again, in terms of tools functionality, in terms of Maya's happiness and your happiness, all good things happen from good, clean, happy edge flow. So we're always trying to work on that, regardless of the shape and form we're trying to create. So we're going to talk a little bit about that and make sure that you guys are pretty solid. And then we're going to delve into some super fun tools that kind of dance a little bit with the devil in terms of your edge flow. We're going to be delving into, in particular, Booleans operations, which are a very powerful tool, but very likely or most often will wreak havoc with your edge flow. So what we're going to talk about is how to use those Boolean tools in an intelligent way. Many people use them, but not necessarily the best and most efficient way, because it's a kind of a reckless tool to work with if you just let it do whatever it wants. So we're going to delve into the smart use of that tool, and we're also going to be getting into some other fun tools like the combine tool and the bridge tool, and good ways to use those tools to help you build the things you're trying to build. Because now we're getting into these level 2 assets, we're making more difficult things, much more challenging things, like the Ladybug, which is just totes adorbs, right? Until you try to build it, and you're like, I hate this thing. That thing is brutally hard to build with what you know right now. After today, oh, some bulbs will be going off, and I think maybe you might find that's not so bad. So we'll talk about some of that stuff that we can do to get you a little bit closer to some of those assets. So that being said, let's delve into today's material. All right, you guys ready for lecture 7? There we go. Thank you for playing. All right, so here we go. Let's talk a little bit about edge flow and polygon faces. Again, it's important to be able to talk about your work in an intelligent way as you describe what you're doing. So let's get some terminology nailed down here. In terms of quads and edge flow, again, I think typically people might imagine that since things have to be, for the most part, four-sided in this class, that's going to limit what you can build, and the truth of the matter is not at all. You can build anything you want. It does add a layer of challenge to what it is you're building, but that doesn't mean you can't do it. So you can create anything you want, organic or inorganic, and all still use nice edge flow and good clean geometry. So quads and edge flow. Again, our goal is to have four-sided faces. Again, for the use of the tools and the speed of the rendering and all that. But four-sided doesn't mean it has to be a perfect square. Again, all of these are acceptable four-sided faces. It's when we start getting down into this area, we're starting to get into face shapes that are not ideal. And we're trying to avoid these whenever and wherever we can. Again, like this analogy, they're bricks to a house. If you have poor quality bricks or irregularly shaped bricks, it makes for an unstable wall. So we're always trying to build clean and happy and efficient stuff. So again, in terms of the shapes for four-sided, you can see there's a whole variety of different four-sided elements, and these are all perfectly acceptable. You know, not everything has to be a gorgeous square. So any and all of those are totally fine in terms of a four-sided face. And we can even get into faces that appear to be triangular in shape, but in fact are four-sided. Because what happens is when you divide one of the edges into two using a vertice, that makes that two edges, not one. So although it looks like a triangle, it is a very cleverly disguised four-sided face. And to that end, let me draw something for you. because any opportunity to draw a picture, I'm going to take it. But I want to show you something about triangles if you happen to have them on whatever it is you're working on. So I'm going to draw just some edge flow for something you're modeling. It doesn't really matter what it is, but let's just say you're modeling something very groovy for a friend. And in terms of your edge flow, let's say you have a triangle somewhere in the midst of your geometry. Something that you have to be very careful of. Sometimes people are under the impression that, oh, okay, so Steve says a triangle with a vertice that divides the edge in half makes that one okay. But what you don't want to do is just stick a vertice in there. I'm almost scared to tell you this, but you can actually do that with the multi-cut tool. But what you end up with is, yeah, this is now kind of four-sided, but this is now a huge n-gon because that divides that one into two edges as well. Not to mention creating what we call those unsupported vertices, because this is one that we could actually delete. So, but the good news is if you have a triangle, look for another triangle, because the cool thing about triangles is if you've got two, you can actually connect one to the other, and then ultimately you end up with two four-sided entities. So two triangles is not a bad thing. One triangle, much harder to try to fix, but again, the multi-cut tool is your best buddy there in trying to find a way to connect those things to each other. Does that make sense? So triangle's not so bad. We can work with those. All right. So, but here's where we start getting into trouble. We've got four-sided faces, but you can see that one of the vertices is dramatically to the interior of the face. And, you know, these very irregularly shaped faces wreak havoc with our tools in terms of their functionality. And if this object is organic in any way or changes shape in any way, like a cord or a wire or something like that, you know, it doesn't have to necessarily be organic. If it changes shape and you have an irregularly shaped face like that, or a non-planar face, which we've talked about already being a no-no, a bend in the face of geometry that is not supported by an edge, if that object changes shape, bends and changes form, you will get often what we call popping or flashing in the geometry. Because what happens is square faces evaluate very neatly and evenly. When you bend a square face, you get a nice even transition from highlight to shadow. Remember we were talking about the normals? They receive light and they tell Maya, does this face get shade or does this face get light? Well, the problem is with triangles and very unusually shaped faces, when they bend, what happens is Maya has a hard time calculating that transition. So it'll say it'll say shadow, 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 highlight, and it will snap from shadow to highlight, and it's not a gradual transition like it should be. And what you see is sort of a flash on the geometry. And ultimately, as human beings, we are drawn to the lightest color element in any given image that we look at. So you're going to look right at that. Why? What's flashing right there? You know, what magical power has this character just unlocked? You know. So point being, geometry behaves poorly with bad structure. Does that make sense? So nice even edge flow, nice even transition as shape change and lighting takes place. So we want to be very careful of that. All right, so again, you might think with a complicated scene like this and all this crazy detail, there's no way everything's got four sides. But the truth of the matter is that as you look around, you realize that no matter how complex the shapes are, they're all four-sided entities that go together to build it. So it's not a limiting factor. It just increases the level of challenge that goes with the modeling. Does that make sense? Okay. So the goal is still to have neat and clean edge flow and nice looking geometry. And the way I like to describe edge flow is like, if you could imagine geometry is kind of like the surface of water, and when you're modeling, sort of a drop of water hits the geometry or the surface of the water, and it creates a big splash where it hits. But as the edge flow transitions back into the rest of the geometry, you kind of ease it back in, just like ripples get more faint as you move away from the point of impact. So you may have dramatic upheaval in your geometry with a dramatic shape change for whatever detail that you're trying to build. But realize that you want to try to ease that geometry back in if you can at all. And you can still have neat and clean geometry with nice even edge flow. even with, again, a fairly dramatic transition in your geometry. And again, everything, you know, when it's very neat and smooth and clean and light efficient, it just looks better. Again, it communicates that level of understanding of what it is you're working in. Now, again, some of the terms that we use a lot, and I'd like you to have a better handle on in terms of edge flow. We're going for efficient transitions in shape. And in terms of the word edge loop, what we're talking about is a loop of edges, and basically it connects back to itself. It's sort of a continuous connection within the geometry. And again, that's an edge loop. So anytime you're talking about that, a continuous loop of edges that move through the object. Now, edge flow is the idea that the direction that the edges move across the surface in describing the shape and form of the object. So they kind of sound similar, but there's definitely a little bit of a difference there. And again, these are the sort of like the girders, if you could imagine, if you look at a building with the concrete stripped away, there's all girders underneath there. And that's what the edge loops are, basically, and the edge flow, the girders, the structure, the support of the object. So we can just see them on the outside when it comes to geometry. All right. Yes, go ahead.
Would what you consider edge flow be similar to cross-contour drawing?
Cross-contour drawing.
Drawing the flow of an object, like drawing like a wireframe, drawing the shape of an object.
I guess it's kind of similar to that idea in that there's almost a motion to the structure. Does that make sense? So I would say in that way, those two are similar because, again, if you look at an object, there's definitely a motion, and we talk about it in terms of edge flow, but there's a motion to the edges as they move across and describe the shape. Exactly, very much like an image. And it's kind of strange, but once you sort of get a greater understanding or mastery of modeling, it's interesting how two totally different people could model the same object and they're going to come up with extremely similar edge flow. So it's almost like there's a natural flow to the edges that complement the shapes you're trying to build. You know what I mean? To a certain degree. There's going to be variation, of course, but it's interesting to me how several people will arrive at the same thing because objects basically, they can be described with very little variation in terms of light, clean, efficient geometry, particularly when you're working with four-sided faces. Does that make sense at all? Or is that crazy talk?
No, makes sense.
Is that okay? Because I don't know. Sometimes I get a little bit deep with my geometry, so it's like, what are you even talking about? You're out of your mind. Go ahead. Yes, absolutely. Absolutely. And again, I don't like to go too far left and right because it makes it harder to describe or harder to maintain structure to the lecture. But what I would say is, can you do that? Absolutely. And what you would be doing is selecting the edges and generating a curve from those. And that's a pretty good hint. If you need some more hints, I can give you some more after class. But yes, you can absolutely do that. Interesting question, though. Very, very left field. I like that one. All right. Online, universe of the internet. Are you guys, you have any questions for me? Anything? Try me. No? Okay. All good? All righty. Well, then we will move on to talk about Booleans. The Booleans operations. Now, Booleans operations, as I said, are a little bit of a challenging tool to work with. They do very cool things very quickly, but as with most things that you do quickly, it's a little bit reckless. So you kind of have to be careful with how you use it. In fact, when I got together with the teacher for model creation, and we were discussing what we would or wouldn't teach you guys between the two classes, he told me straight up, do not ever show them Booleans. Never, never, never. They're the devil and don't do it. And I said, well, here's my philosophy on that. I can either pretend Booleans don't exist and don't teach them to you, but you guys are going to find them and you're going to use them and somebody's going to get hurt. or I can show you how to use it properly and you don't hurt anyone else or yourself. So I'm a teach it to them, they can handle it kind of guy. So I am going to show you Booleans despite his suggestion. But he was okay with me doing it. But we're going to do it in a smart way. As I said, it's a powerful tool, but it's a little bit messy. So you kind of have to pay attention to what it's doing. And again, there's not a coincidence that we talked about EdgeFlow before we get into these guys, because they definitely do their best to destroy EdgeFlow. Something to think about with Booleans operations, in some instances, these tools, dependent on the order of selection, it changes how the tool behaves. So there's a lot of different things you need to look at. So let's take a look at the Booleans. If you go to Mesh, you will notice under that you will see the Booleans operations. We're going to be talking about the union, the difference, and the intersection, 3 different varieties of Booleans operations. All right, so to help us with Booleans discussion, more pictures. All right. Okay, so first one we're going to talk about is the union operation. So let's take a look at 2 spheres, and let's just say I take these 2 spheres and I select them both. In this instance, the order doesn't matter. And I run the Booleans union operation. What the union operation does is it takes the element of the geometry that you cannot see and it removes it. Much like we try to keep all of our models nice and hollow on the inside, same thing is going on with the Booleans tool. So in terms of its use, whatever is on the inside is going to be removed. So again, if I select these 2 pieces of geometry, they have sort of intersected at this point. When I run the Booleans union operation, I get this. Again, the parts of the geometry that are on the inside or the interior are removed completely, and what's on the outside remains. So if you take a look at my character here, my little Lego guy, I just took my Lego guy, I created a sphere, shoved it into his chest, and ran the Booleans union operation. So as a result, the part of my chest, which is behind the sphere or hidden by it, is gone. The parts of the sphere that are inside of his chest is gone. And it literally fuses these 2 pieces of geometry together into a single entity. And if you look at it, you can see in terms of the edge flow on my character and the edge flow on this sphere, they are not connecting up. The end result is not 4-sided faces in here. I'm definitely ending up with n-gons as a result of this operation. However, you and I both know that to create that type of shape change out of what I had geometry-wise on my chest, that would be very difficult to do with just what I had to work with. Does that make sense? So obviously, this is a shortcut-ish to dramatic shape change within 2 fairly complex objects. Now, let's take a look at the intersection. Now, the intersection is kind of the opposite of the union. So what happens in the intersection is I take my 2 pieces of geometry, I crisscross them a little bit, I select the 2 pieces, I run the intersection, and what it does is it removes all of the geometry you can see, and it gets rid of what you can see, and it keeps what you can't. So it's sort of the inverse of the union. So where these 2 things crisscross, it's saved. So with that in mind, same idea. I took my character and I shoved a sphere into his chest and I ran the intersection. So the part of the sphere that was covering my chest, gone. The part of the sphere, or the part of my chest that was covering the sphere, gone. But what I'm left with is, again, a fusion of the sphere and the part of my chest that was hidden by the object from its exterior. So again, it sort of fuses them together. And again, you can see this edge flow is definitely not yielding quadded geometry, very messy. But this would have been very difficult to do under regular circumstances. Does that make sense? Okay. Now, the third one is the difference, and this one's pretty funny too. The way I like to describe the difference in terms of the way this tool works is it's kind of like using one piece of geometry to take a bite out of another one. Does that make sense? One of them eats the other. So, for example, if I've got these two objects and I intersect them and I run the difference tool here, what it'll do is it will take one object and subtract it from the other one. So I lose the object and whatever sort of crossover element there was. And it preserves the other side. So one piece of geometry subtracts from the other one, as it were. It takes a big bite out of it. So again, if I take a sphere and I stick it into my chest here, the part of my chest that was inside is gone. The sphere is completely gone. But what you'll notice is in the interior of my chest cavity, which should be just wide open like a chocolate bunny, right, if you took a bite out of it. But if you look in there, you can see it's sort of fused with the interior of the sphere. So it did sort of cauterize the interior here and make it so that I have a hole right through my chest. So I subtracted the sphere from my chest. All right. You guys ready to play with these things? Don't be scared. I'll be right here holding your hand, virtually in some instances. So let's go take a look at Booleans operations. So I'm going to be playing with Booleans. So I want to set my project to my Booleans folder. Files, set project, and I choose my activity file. And then file, open scene, and you'll see I have my Booleans activity. And I'll open that up. Now, in terms of this first Booleans activity, because I have more than one, I just want to show you it's exactly three of the exact same object. I've got a cylinder that intrudes on a cube about 2/3 of the way in, and all three of those are the same. And I colored them just so you can see the fun stuff that they're doing. Now, in terms of this first operation, what I'd like you to do is select both pieces of geometry, and then under Mesh, Booleans, choose the union operation. And again, what Maya's going to try to do here is stick these two pieces of geometry together. So here we go, union. All right. Now, I'm going to show you from sort of a X-ray view what happened there. Again, the part of the cylinder that's inside the cube is gone. It just chomps it right off. And the part of the cube, and I have to go inside the cube to show you, the part of the cube that was inside the cylinder has been removed. So I can actually see right up into the cylinder. And you can see Maya is trying to kind of connect these things together, ish, but you can see this is obviously a big honkin' n-gon out here, and this is a big honkin' n-gon out there as well. And in terms of fixing it, what do you guys think you would do? Yeah, I'm going to need my multi-cut, right? I would probably use the insert edge loop first, just so that I don't have to go click, 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 click. What I would do most likely is go to my mesh tools and use my insert edge loop and drop a couple of edges in here like this. Get those in there. And you'll notice it cuts this surface, and it cuts this surface, and it cuts this surface, but it won't cut these guys. Why is that? Why won't? Not necessarily that it won't wrap around. It's a good thought, though. Something's definitely wrong with it. It doesn't like n-gons. The insert edge loop tool does not like n-gons, therefore it won't cut these. So what I end up having to do is throw some insert edge loops in there to get those things going. Then I have to go back at it with my multi-cut, and then come back in and try to connect these edges to each other in an effort to try to clean this up a little bit and, again, try to quad it out so that it looks a little bit better, and, again, it creates a little bit more sound geometry as a result of that adjustment. Does that make sense? Okay. And what you'll start to notice is, yeah, I can probably clean that up and fix it, but, you know, and I'm trying really hard to make that nice, neat, and even, but it still looks a little bit messy. Does that make sense? It starts to look a little bit like a duct tape and bubble gum job, which sometimes that's what it takes to make it work, but if I can avoid that, I'm going to try. But do you guys see what I'm doing here and why? Okay. So again, that's the union operation, and again, I've got to fix it after the fact because I've created terrible geometry. Yes?
You couldn't go straight across through the cylinder? Like edge cut straight across through the cylinder?
Could I edge cut straight across? No, because it's actually fused these two objects together. So I can't, if I try to use the insert edge loop tool, it's going to go, no, I'm not even going to cut that. For example, if I just get my insert edge loop, I could try it, you know, and I always, you see, it's throwing edges into the cylinder.
I meant if you were to multi-cut from the vertex on the left side to the vertex on the right side, you see what I mean?
From here to here?
No. From one side of the cube to the other, like trying to cut through the cylinder. Yeah.
Oh, you mean in terms of with the multi-cut tool, could I just sort of click a spot over here and then click a spot over here and try to get it to connect?
Yeah.
But you can see the issue I'm running into is it's not lining up. You know, this one, it looks like it's fairly close. That one is definitely off. You know what I mean? Should you try stuff like that? Yeah, absolutely. By all means, give it a shot. You don't know until you give it a try. You know what I mean? And the worst thing that'll happen is Maya will give you its little rainbow wheel of love and go night-night for a second. And you launch it back up and you're back at it. So worst case scenario is not even that bad. But you can see that the tools are just not functioning the way you'd like them to, and then you're going to end up having to fix that again anyway. But it's a good thought. Why not try it, you know? Yes, go ahead. That's absolutely. Can you select and delete those? Absolutely. You can just delete those out of there and then try to recut the edge flow. Absolutely. Just be aware that it's going to leave that vertice behind unless you use the delete edge vertex tool, which gets rid of the edge and the vertex at the same time. So you just got to be aware that that's there. And again, if it's an unsupported vertice, you can select and just delete that also. But again, just more of a mental note. Make sure you're, oh yeah, that's right. I deleted the edge. It's the vert's still there. All right, so that's the union operation. Let's take a look at the next one. Select the two pieces of geometry, mesh, booleans, and let's do the intersection. Now, in the intersection, and again, I will do my before-after with the wireframe. What it's doing is it takes whatever's on the outside and gets rid of it. And it just saves the inside. So the part of the cylinder that was on the inside, it keeps. The part of the cube that was on the inside, it keeps. All the exterior is removed. So you'll notice here that the cube is yellow. So when I run that tool, it uses the part of the cube that was on the inside to seal the cylinder. And then the cylinder remains largely unaffected except for the part that was sticking out of the cube, which has been removed. And of course, in terms of this face, I'm going to have to use my multi-cut tool to try to recut that surface to make that quadded. All right. Now, here's where we get into the difference, and this is the one that one piece of geometry takes a bite out of the other one. So if I select the cylinder first, and then I select the cube second, and I do mesh, booleans, difference, what it's going to do is it takes the cube, and the cube takes a bite out of the cylinder. So what I'm left with is the cylinder that was outside of the object, and again, the cube just sort of bites and takes that piece away. Now, the opposite of this being, if I select the cube first and then the cylinder, and then I do my mesh Booleans difference, the cylinder takes a bite out of the cube. And as you would imagine with this piece of geometry, it would be kind of difficult to create that shape using an extrusion. You could, but it would be kind of hard to do that particular element there. So again, the part of the cylinder that was on the outside is gone, and the part of the cube that was inside the cylinder is gone.
You must be a mind reader. Just ask that. Does the order of selection make a difference?
I tell you what, the midichlorian count is very high on me, so yes, it does make a big difference which one you choose first. So with the difference one, the other two, it doesn't make any, it doesn't affect anything. Now let's get into some more fun stuff. I'm going to select these guys here and just delete them, and then there's another layer below that. Dun dun dun, and here's where you guys can try to do some Boolean fixing, and Brian and I will walk around to see how you're doing. Again, this is my goal. I'm trying to create a cylinder out of a cube, which, you know, seems like witchcraft, but I can use my Booleans, which operation to create something that looks somewhat like that. Which one will give me that? The union ones, right? So I grab the two pieces, mesh Booleans union, and you see it does actually connect it, but then I'm going to have to go in and clean that up. And here's how I would like you to do that, and this is a simplified version, but it's the same kind of idea. I've got these two objects, and I'd like to bring them together. So something that I do, particularly when I'm using my Booleans operations, when I'm using my combine operations, when my bridge operations, when I'm doing stuff like that, it's important to be able to see the edge flow of the model. So what I like to do is I'll go to shading, and I'll choose wireframe on shaded, which is a great way to see not only the shaded parts of the geometry, but the edge flow of the geometry as well. So I don't have to select it to see the edge flow. Now, here's a neater, cleaner way to use that Boolean union operation. So I need to connect these two things together. And I can see that these edges are going to connect, these edges are going to connect, but this edge doesn't have a buddy. Well, this edge doesn't really have a buddy either, so I could probably connect those to each other. And I notice that I can do that all the way around. So what I'm going to do is take my cylinder and just move it out of the way. And one of the great things about zeroing out your transformations is if I freeze a piece of geometry here, if I move it, if I plug in all zeros, it's going to go right back where it was. That's a great way to kind of get your stuff back to where it was and not worry about, oh shoot, did I lose position? No, freeze your geometry. So in terms of my edge flow, again, what I've got here is not going to do it. So I'm going to use my multi-cut tool, and I'm going to connect this edge to this edge like that, and take this bad boy, connect it there like that. So now, when I select this guy, and I zero him out so he goes back where he's supposed to go, I can see every edge on one object has a partner edge on the other one. So then when I run my mesh Booleans union, they connect nicely, and I don't have to do anything because the edges are all lined up. Does that make sense?
Yeah.
Okay, so what I'm going to do, and Brian's going to help me, we're going to walk around a little bit. I want to see you start trying to quad this guy a little bit, see how it's going, and then do this guy the way I showed you, and let's see how we do with those two different variations of using the union tool. Okie doke? Yes?
Remind me, how do you freeze geometry with the command to do that?
Anytime you're trying to freeze geometry, all you have to do is select the geometry in object mode. And if you go to modify, you choose freeze transformations. And what that does is zero out everything except for scale, which goes to 1/1 scale or actual size. Does that make sense? And that basically, again, it's a bit of a misnomer because it doesn't lock the geometry in place, but it gives it a new starting point.
Okay.
All right? All right, so Brian and I will walk around, see how you guys are doing with that. Booleans union here, same thing as we're doing there, but this time You're trying to use insert edge loop and multi-cut to fix it. As opposed to this one, we're using the multi-cut to fix it. But what we did here is we created the edge flow we needed first, and then we did it.
So we're doing
After the fact, exactly. Just so that you can see the pluses and the minuses of both. Because it's not necessarily bad. You just have to, going into it, you have to know what to expect. Does that make sense? Yep. Very good. And you can see the Booleans tool does give you some pretty interesting quick result. It's just it tends to be not so happy geometry-wise. But if you know that going into it, you can prep your geometry. And the bottom line is your choices are fix it after or fix it before. And I try to fix it before whenever and wherever I can because it tends to look better. Very good. How you guys doing? Having fun? It's under mesh. Yep. Yep, right up at the top. How you guys doing? And you can go straight across on that one. And typically what you would want to do is put one in and hit enter and then do the other one. Yeah, you don't want to jump around to all the corners because it might yield an unusual result. You want to do cut in one, then cut in the other. It should be in the activity files folder. And I don't know where you put that on your computer, but everybody puts it in a different place. But if you do a search for it, you should be able to find it. What's that? Booleans activity, yeah, that's the one. Good. It could be that they didn't line up perfectly when you did it, so you're going to have to merge the vertices, and then that should eliminate that.
Just playing with it.
Yeah. No, that's what I want you to do.
But I noticed that the tree went all the way through.
Mm-hmm.
So I thought it was supposed to go through if it was like connected as one.
Yes, because typically what happens with the insert edge loop tool is it won't cut faces that have more than 4 sides to them.
So, I mean, I thought if this was connected as one, wouldn't it kind of just, I guess, stop and not go through? Or
it should, yes. But what I would say is let's take a look at your options on the insert edge loop tool. It's under mesh tools. See where you're telling it to fix? Yeah, what you're saying there is, hey, Maya, you know what? Why don't you fix my geometry for me? I know you know how to model. Go ahead. That should be off, yes, because Maya's going to make new and different edge flow, not necessarily good. Does that make sense? Because it's just going to, unfortunately, it's a machine, so its limitations are it only knows what we tell it, and it doesn't understand art at all. So it will create bad geometry if you let it. Yeah. Yeah. No, it seems like you're doing okay. Yeah. Yeah. No, like I said, it's a handy tool sometimes. It's a dangerous tool sometimes. Got to decide is it your buddy or not. What's that? Oh, I didn't put you on the end. Remind me at the end, then I'll put you back on it. All righty. So quick hands up. Is anybody seeing crazy shading errors of any kind? Any weird zigzaggy stuff on your geometry? Okay. And the reason I bring that up is because the Booleans tools tend to create kind of weird stuff happening because what you've created is a very sort of unnatural thing. Have you guys ever seen the movie Frankenstein? Yeah, Frankenstein. The idea of Frankenstein is some guy went around digging up again, it's a story. This guy went around digging up bodies of people, cutting off parts and sort of sewing them together. Yeah, sorry. Just a movie. It didn't really happen as far as we know. But point being, he basically sewed these parts together from all different people to make something. And it was very unnatural as a result. And the Booleans operations is kind of like that. You're creating something very unnatural because there's a node for this piece of geometry and there's a node for this piece of geometry. And now you tell Maya, you know what? This is one thing. It's a new, totally different thing. And it's sort of a blend of the two. How do you like that? So Maya's like, whatever. I don't care. But typically, you'll see kind of weird things start to happen. And I've noticed with Booleans operations, if I'm doing a lot of them in a particular scene I'm working on, the file starts to act squirrely. Like some of my tools don't work as well. It starts to crash on me. So there's this cumulative, you're messing with the danger zone, Steve. So that can happen with Booleans. And again, that's one thing I want to warn you about, that does happen on occasion. And sometimes what I end up having to do is export my geometry and bring it into a fresh file just to sort of clean it and remove all of that craziness that seems to be building up with it. So just be aware. When weird stuff starts happening, ask yourself if you've been using Booleans or not, because it does sometimes lead to issue. So I just want to make you aware of it, because it is very unnatural what you're doing with it. But just so you know. Now, something I wanted to put out there for you with this last little bit, because you're wondering, well, what's the sphere and the cylinder thing about? In terms of these Booleans operations, they're very handy for attaching things to each other. But what you have to be aware of, since we've determined edge flow is a big ticket item, is that you have the same number of edges on both objects. And to be honest with you, when it comes to modeling, you want to model with even numbers of edges no matter what it is you're building. Even numbers of edges are very important, particularly for purposes of quadding and for purposes of attaching things to each other, because we often do that. So even numbers is good. But in terms of your geometry, if I'm trying to attach, because again, to extrude a sphere out of a cylinder would be very difficult to do, because to get that kind of even, smooth curvature, brutal. So if I'm trying to do that in terms of my object, if I've got a 20-sided cylinder, how many sides need to be on my sphere? Also 20, otherwise they won't match up properly. And if you're wondering, well, will Maya make the leap and fix things for me if they don't line up perfectly? And you can see I can actually select these two objects and run my Booleans union, and you'll see, no, Maya could care less if they don't line up right. And it will yield n-gons in some instances because those vertices are ever so slightly off, and that's all it has to be, is ever so slightly, and you've created an n-gon. So you got to make sure when you're attaching these things, you got a nice connection between the two objects so that when you run it, nice smooth attachment. Now, the other side of this argument is, okay, yeah, it's really hard to create a sphere out of a cylinder. That's brutally difficult. But what if I instead created a cylinder out of a sphere? Because that's much easier to do. So in this instance, what I'm going to do is come in and grab all of the faces on the end of my sphere. Just want to show you what I have selected. And then I do my edit mesh extrude. And this time, rather than trying to create a sphere out of a cylinder, I'm going to use a cylinder out of a sphere. And I end up with a nice shape here. And this I can fix either using the scale tool or whatever to flatten it out or just flatten the vertices. But here I've created the exact same thing, and I didn't have to use a Booleans operation. So sometimes Booleans seem like the magic fix everything, but sometimes it's just you're not looking at it from all possibilities, because sometimes there's an easier way to do what you're trying to do. You're just going about it the hard way. that make sense? So I don't want you to feel like, you know, Booleans are the Hail Mary every time you're in real trouble. Booleans, you know, no, maybe just if you went a different way in terms of how you created what you're creating, that's the solution. So I'd like for you guys to create this one. And something I want to show you with the extrude tool, because this often freaks people out in terms of the extrude tool. You'll notice that when you do an extrusion, sometimes you get that kind of result. And what's happening is when the extrude tool extrudes, it's basically looking at the face. It averages the faces, and it's moving based on the angle of the face. And that's why you're getting that sort of outward crazy extrusion thing going on. But you can switch it by clicking this little icon here, and that changes you from world to object space. So if I click this little icon here, I'm extruding on true axes and not using the angle of the face. So that allows you to do an extrusion on pure axes rather than having it go off a kilter as it was doing before. Right. I'm not sure I understand the question, but I followed the word gun. Yes. I see what you're saying. Can I modify this tool to follow an object on a different object on the same axis of the first object? And what I would say, because that's a crazy complicated question, but that seems to be your area of specialty. What I would say is, as an overall blanket statement, try to build everything on pure true axes when you're modeling, because it's a much easier method to work on. Could you extrude off axis? Absolutely, but it complicates things dramatically. If you work off of true axes and then move the object into the new position, you're going to have a higher level of success and less sort of squirreliness with tool behavior. Yes. Yes. Mm-hmm. Well, it gets complicated in terms of the tool use, but do we know how to change the orientation and positioning of pivot points? How do we do that? That is correct, the Edit Pivot Point tool. So in terms of adjusting how objects align themselves, yeah, that's not just move, that's also its rotational axes as well. So if you're trying to restrict something to a specific axis, you can modify it using the Edit Pivot Point tool. Does that make sense? Yay! See, all this silly stuff comes together. You think I'm teaching you wacky, unrelated things, right? No, they do stitch together. Okay, good. Excuse me. All right, let's take a look at some more fun tools I want to show you guys. And it's along the same lines in terms of creating more interesting wackiness, connecting things and attaching things. And I'm hoping what you guys are starting to realize is, oh, maybe this is an opportunity to use some of this stuff to make, say, the ladybug, or you know, some of those other more super complicated things. How do I do that? Maybe that threaded asset, although we have a really cool video on how to do that the best way, but you could use it like that. But let's take a look at the combine and separate tools, because these are super handy also for connecting things to each other. So again, I'm going to show you how to use these properly. Excuse me, this seems to be like the month of lots of frogs in my throat. I'm not sure what that's all about, but this has been one of those months. All right, so we're going to go to File, Open Scene, and let's take a look at the combine and separate activity. And there's two little fun things in here. The first one is showing how combine and separate work. Now, in terms of this geometry, you can see it's 3 separate pieces. And if I grab them all at once, I can move them together. However, when we get into rotations, they all have their own little thing going on. And, you know, heaven help us if we scale, because it gets all kinds of messy. But how can I get Maya to treat this like a single object, even though it's multiple pieces? And we talked about grouping, we talked about parenting. Those are actually the preferred methods. But there is another thing that you can do, and that is combine geometry. And what you do to do that is select all the pieces, and you go to Mesh, and you will see Combine. And literally what happens is Maya pretends that instead of many pieces, it's one piece. And what's handy about this is no matter where you select it, Maya thinks of it as one entity, and you can move it together. You can now rotate it as a single object, and if you scale it, each piece maintains its proportion and shape. Now you're wondering, okay, so this is like permanently glued together. No, not at all. Combine is just an idea. So can I get it to come back apart again? Absolutely. If I go to Mesh, Separate, then Maya is actually going to break that thing back into separate pieces. And what I find very funny is basically each one of these objects had its own little node that represented it, and each of those nodes had a material assigned to it. And when I combined it, it maintained all of its materials. But watch what happens when I separate it again. Here it is all combined, right? Yay, one material. And then when I do my Mesh Separate, Maya goes, oh yeah, okay, now they're all back to separate entities. Oh shoot, what's that thing made of? Yellow. It just randomly assigned.
But they were all orange.
All orange. You never know what you're going to get, because Maya suddenly doesn't know what to do. Because again, you're creating a little bit of an anomaly when you're doing this kind of thing. Does that make sense? And you'll notice that everything needs to be renamed because Maya has no clue what it is anymore. So just something to be aware of in terms of that combine and separate. Why do we use parenting and grouping? It's actually a smarter way to go about getting things to move together. But sometimes this is a good solution in some instances. So just being aware of what it does and how it works. However, I want to show you what combine and separate is really best used for, and that's when you're physically attaching 2 separate objects to each other. Because again, on occasion, sometimes we do need to do that. So let's just say I've got these 2 cubes, and I want to connect them to each other. What I'm going to do is literally attach one to the other, and then I'm going to merge the vertices. But 2 things have to happen. Number 1, in terms of merging vertices, it is important to note that you cannot merge the vertices of 2 different objects. Maya will not let you do that. So it has to think of it as one thing before it will let you actually physically attach them to each other. The other thing you have to be aware of is if I physically attach these 2 cubes together, I will have faces on the inside of the geometry. Does that make sense? Which we know is a no-no. We don't want geometry that's being calculated and lit and rendered and affecting the way the geometry behaves that we can't see. Those interior faces that we were worried about when we were modeling before and fixing the gun, same thing holds true. So what I'm going to do is first, since I'm going to connect these 2 guys to each other, I'm going to delete the faces on the interior so that they're nice and hollow, so that when I do connect them to each other, they'll be hollow as they should be. Now, as I said before, you cannot combine 2 objects, or you cannot merge the vertices of 2 objects that are separate. So what I'm going to have to do is select them both and use Mesh Combine. So now Maya thinks of them as one thing. They're not even really physically connected, but in terms of their behavior, Maya thinks of them as one thing. So now what I can do is go to vertex mode, and I could literally select a vertice from one, and I can attach it to a vertice of the other. Now, in looking at that, you might be thinking, wow, that's going to be really hard to do, because how am I going to make sure I line those things up? Well, here's where I can use some really fun snapping tools that Maya has. If you look at your keyboard right now, V, as in Victor, is the key for snap to point, and vertices are points. So if I hold down the V key, I can literally snap my vertex to any point I want. And you'll see, as long as I hold down the V and my left mouse button, I can snap it to anything, even on itself. But what I want to do is attach it right over here. So I'm going to drag it towards the vertex I want to attach it to, and it attaches. And I grab it. Well, it's in the same space. It hasn't actually connected yet. So now hold V, and again, snap that one over. Select this one. Again, hold V, snap that one over. Select this one, hold V, snap that one over. And now that they are actually on top of each other in terms of their spacing, now I can combine, or I can actually merge those vertices together. And you guys know the tool I want for that. What's that? The merge tool, right? No secret there. Edit mesh, and I'm going to go to my merge. And remember, we have to be very cognizant of threshold. If threshold is too high, stuff sticks together. So you want it to be a, a fairly small number. And again, the one I like to use when I'm merging vertices is 0.001, because that ensures that the vertices have to be like right on top of each other to stick together. Yep, you just go into vertex mode and snap the vertices, hold V on your keyboard and drag them over to one another. And as long as you hold down the left mouse button, the vertice will drag. Let me take a quick peek and see how you guys are doing with that. Combining your vertices, or combining your objects and then merging your vertices. Yep, they should be if you select them all and use your merge tool. Because just using the snapping tool does not fuse the vertices together. All that does is bring them to the same point in space. One of them is stuck to the other. Then you got to use your merge tool to physically glue them together. Absolutely. Just select one vertex and try to move it, and both pieces of geometry should move together. If they don't, you didn't merge it. You see? Those guys did not attach. So you want to make sure you combine first. Snap those vertices into plates, and then you can test it by moving it. And then, of course, hit Z so it goes back to where it's supposed to be. There you go. Good. You have to hold V down. Yeah, V first. Yeah, hold V. Now move it. Yep. Oh, there's, in terms of, do you use Photoshop at all? Oh, okay. There's a lot of different ways to do exactly the same thing, and there's not a right or wrong. But in terms of this approach, I just want to show you guys the combine tool in terms of how to merge the vertices, because this is a very easy and straightforward way to see how to attach those things to each other. I try to avoid tools that look very much like magic in terms of what they're doing, just because they don't explain as well. Does that make sense in terms of what you're doing? So I try to find ways that are either the easiest way to do something, or it's easy to see what's going on. And typically, it either builds off of something we've already talked about, because we've already talked about the merge tool, or it leads to something we're going to talk about. Does that make sense? So like under those parameters, that's how I choose which tools I show you. So does that mean that that's the only way to do that? Oh, hell no. Not at all. There are many ways to do this. It's under Edit Mesh. Yeah. Yep. Most of the, yeah, no worries. Most of the stuff we work with is under Mesh or Edit Mesh, so that's a good place to start in terms of looking. How'd you guys do? Pretty successful with that? Excellent. That's what I like to see. Happy merging of vertices. All right, excellent.
I just yanked them out.
Yeah, as long as you do a point selection of the vertex, and if you move it and it stays together, then you did it. If they separated from blue from green, you know you did it wrong. Yeah. And that's what you do. You just test it, grab it, move it, and How's that, Brian?
There we go.
Hey!
Good.
Everybody can hear me again. Hi, guys. Welcome back. I didn't say anything cool. It does all kinds of interesting things. It's going to look very similar to the exercise we did with the combining, but it's got some interesting variations to it that are helpful when you're dealing with objects that have handles and so forth. But let's take a look at the bridge tool, and we'll play with that a little bit. And this is not one I have used a ton in the past, but I found that it's actually pretty fun. Let's go to the bridge. Here we go. All right. Now, in terms of the bridge tool, you can see this one's pretty funky, what's going on. What the bridge tool does is, again, it connects geometry to each other. And in terms of its behavior, you know, it's one of those things where, oh, yeah, I can't do it because they're separate objects, so I need to do what? I got to combine them. So I got to select them both, combine them, and then I can get into stuff like I want to bridge these two things together. Now, in terms of the behavior, again, the issue you're going to run into is you want to have these areas open when you connect them to each other. Otherwise, there'll still be some faces in there. But in terms of this tool, again, I really like some of the fun stuff it does in terms of connecting surfaces to each other. And a couple of these fun little things that pop up with the dialog box here is like the number of divisions. And what that's talking about is how many edges are in between this connection. So it's a little bit different than the merging of vertices and combining, in that you can add extra edges. And where this becomes helpful is if you get into some of these other things, like, say, for example, twist. Twist will literally turn the geometry somewhat to give you a little bit of a twisting function. And again, there's a point where you've gone just too far and it freaks out. But you can, obviously, with fewer divisions, you don't get quite as smooth a result. So by increasing divisions, when you go into the twist, you get a little bit more fluid transition there. Also, in terms of fun behavior, the taper function, which kind of has it either taper in or taper out. And that's kind of interesting, again, in terms of some interesting shape change. You can make it breathe. So again, that the bridge tool there, very cool. In terms of bridging between objects of different size, it'll do that too. Again, the big ticket item is you got to make sure that you combine your mesh, but you can attach faces to each other. And you see it's trying to go shortest distance from here to there, so it's, wow, it goes through the bottom. But you can attach different size faces to each other and get a nice result. Let me see if I can get that to go. And again, that taper function is pretty cool. Divisions allows you to increase or decrease the number of edges in between in terms of your connection. So depending on how smooth it needs to be, that's pretty fun. But by far, I think one of my favorite things that this crazy tool does, again, I'm going to combine these guys, is I'm going to grab the faces here and grab the faces here, and I'm going to do a bridge. And one of the really fun things that this tool does is it actually creates a curve inside the geometry that it makes. And in terms of what you can do with this curve is just like polygons have vertices, edges, and faces in terms of a component that you can manipulate, curves have a component as well. And you can grab the, let me get back on my curve here. Again, this curve, it's basically, in terms of what is a curve, it's a line, but it has physicality to it. So if you can imagine a physical line, and it has components as well. So I'm going to grab the control vertex of the curve, and you'll see it creates a series of points along the curve, and you can literally grab those points and move them, and they change the shape of the object. So even after you've done your little bridge, you can alter the shape of the transition between the two pieces there. So you can make some pretty funky looking pieces of geometry utilizing that. Now, one thing I would strongly recommend you not mess with is you'll notice that at the beginning and the end of each curve, there are also points that you can manipulate, but you can see the result you get from manipulating those are not so good. But if you grab the control vertices more in the middle, you get much nicer transition in terms of the behavior. Does that make sense? So a little bit easier to work with those guys. But pretty fun, again, changing the shape after the fact. Sure. I'm doing a bridge tool. And again, I'm just showing you that in terms of how you can bridge from one to the other, first you have to combine them, mesh combine like we did with the other two tools. Well, what I'm doing is you'll notice I have those little dots on my faces as an option. You can do that. And what's nice about that is it allows you to select like that. Yeah, it'll get the side ones as well. That's a preference. If you go to Maya Preferences and use the selection category, it's select with not whole face, it's select the other one. The other one. There's two options for selection. It's select with whole face and select by something. So you just choose the other one. Center, thank you. Choose center. So I grab the faces there, grab the faces there, and then edit mesh bridge. And again, it connects the two to each other, and the fact that they're not on the same axis or anything doesn't make any difference whatsoever. It connects the two together. Again, it's got the divisions adjustment that you can make to have fewer or more divisions. You can taper it. You can twist it. But what I was messing with before was the curve inside the geometry. Yes?
I just had something really weird happen. It just basically deleted the faces and deleted like side of its own though. I graded it.
Okay, that's right. Open the file again. Yeah, no, that's okay. You just open the file again. Sometimes weird things happen based on either what you're doing or it just didn't calculate well, so Maya didn't know what to do. Yeah. Yes, look at how many divisions you've got set for. The number of divisions will, if you increase the divisions, you get a smoother transition between the two. Because you see, if I do this and I don't have very many divisions at all, it's going to go straight also. Did you select the faces? Okay, well, I'll walk around and see how you guys did. But again, what I wanted to show you guys is in the creation of this, this fun little bridge, the fact that we can actually select the CVs or the control vertexes of this curve and change the shape of the object. They're inside. If you go to your bridge tool in your options, I think you can tell it to not have that curve in there, but if you've got it set for smooth path and curve, that's going to generate that curve inside that you can manipulate after the fact. What's that? Make sure you have that turned on. What's that? No, you cannot. You must do that beforehand. Yep. If you've already done the operation, it can't sort of stick that in there. Does that make sense? Yep. If you go to Edit Mesh, Bridge, again, Options, make sure you're set for Smooth Path and Curve. Well, what I did was I went to wireframe mode so that I could actually see inside, and you see that right through the middle of my geometry there is a curve in there. Okay, well, like I said, I'll walk around and see how you guys are doing, but when you run that tool and you have that generate a curve and smooth transition, it'll give you that curve, which you can then get to the components of, select and manipulate. And again, in terms of creating like interesting handles and stuff, that's a really fast way to do that. But let me take a peek. I'm going to walk around and see how you guys are doing. Oh, if you want to, sure. Yeah, walk around. Okay. Undo it. Keep going. All right, now. All right, and let me see your options for your bridge tool. Yep, smooth with curve. See? Now you just got to up your divisions because you don't have enough. Oh, cool. How do you smooth it? Oh, actually, we're going to talk about that because it does look a little striated there. I know what you're talking about, but we can make an adjustment to that. Or faceted, I think, better word. Cool, cool. Looks pretty good. How's he doing? Has he got it?
No.
Okay.
I looked into the show. It wasn't turned on.
All right.
I mean, it worked.
The curve. Let me check your options because I'd be willing to bet the ranch you didn't switch it on. Hit Z and go back before you did it because you can't do it after you've done it. Yep. Keep going. Keep going. Keep going until before you did it. Keep going. Keep going. All right, great. Now, let's go to your bridge options. Edit mesh. Oh, yeah. Bridge. You got it set for smoothing curve. Right. Now hit. Now do it. And I can already see the curve is in there. Yep. You know, it would be like painting a painting and going, you know what? I would rather paint on metal, not canvas. Even though you've already painted, I can't undo that. You know what I mean?
Are really important when you get through
You have to put your cursor over it, just like you did with the geometry. Put your cursor over the curve, not the geometry, over the curve, and hold down your right mouse button. And you'll see control vertex. Now you're dealing with the CVs. Back up a little bit. They're little pinkish purple things, and they're sort of offset from the curve, and they affect its manipulation. Oh, make sure you're moving the CVs, not the vertices or the faces. Let me see. Okay. Now, did you combine the geometry?
She didn't. She's getting the same thing.
Okay, because you have to combine it first. So make sure you've combined it, because that is a big piece. Okay, object mode. You have to select them both in object mode and then combine them. Okay, now select the faces on the ends of each one. Mm-hmm. Good. Good. All right. And then go to, these are your bridge options. Choose smooth attachment and curve generation. Yep. Now do it. Oh. Oh, did you get some on the side as well? Tumble it. Let me see the other side. Yeah. You can't have anything else selected. It's got to be just the guys on the end. Because if you're trying to do the side also, it doesn't know what the heck's going on. Does that make sense? Because it's totally confusing it. So make sure you just have the ones on the end. I bet you that's going to be the difference for you. I bet. What? Yes, you have to give it enough divisions to generate geometry. More divisions is more geometry, but you can adjust that after you do it even with the interactive dialog box that pops up. So what do you guys think? Is this a pretty fun tool to work with?
Hell yeah.
This is different, right? It's pretty neat. Now, just to kind of give you a little bit of a highlight about those guys, you might be wondering, well, what's this curve thing? I don't understand. What am I manipulating? What's going on there? If you recall from the beginning of the class, we talked a little bit about there's more than one material that you can build things out of, right? Polygons, subdivisions, NURBS, these are all different materials that you can build stuff out of. Just like in our world, we can build things out of wood, we can make them out of metal, we can make them out of glass. A lot of it has to do with what do I need it to do that determines which material I go with. So for example, if I'm building something that I'm going to be putting into my microwave, right, I can't make it out of metal because microwaves no like you to metal. And I can tell you that firsthand. If it's something that's going to go in the dishwasher, you know, I can't make it out of plastic or it'll melt. So again, depending on what you need the thing to do often determines what the best material to make something out of is. This is primarily a polygon modeling class, so mostly what we're working with is polygons. However, this curve, a line that has physicality to it, is a different kind of material. And this is a NURBS piece of geometry, NURBS. And that stands for non-uniform rational B-spline, which is what happens when you let engineers name stuff. You end up with names like that. But the short version of what the heck is a NURB versus a polygon is this. On a polygon object, we've talked about that between 2 points, there can only be a straight line. So if I'm trying to achieve curvature, I'm going to need lots of straight lines in order to get that. And there'll be a point at each one. Does that make sense? Again, that's sort of the rule of polygons. Now, the idea for NURBS is between 2 points, there are infinite points. Because a line can be conceived of as a series of points. So between 2 points, you can have all kinds of crazy curvature going on a NURBS surface. And again, it just behaves a little bit differently, much like metal is different than wood. You can make a bowl out of salad, a salad bowl out of metal, you can make a salad bowl out of wood. It's just, what am I looking for out of it? So can you build anything out of NURBS versus polygons? Absolutely. It's just a choice. Does that make sense? So this curve that we're working with, it's a piece of NURBS geometry, and it has components just like polygons do. They just have slightly different names. Yes? Can you bridge together different shapes? Try it. Well, number one, I would say make sure you combined it first and make sure you've selected faces on the surface of each object and then try to run it. But again, there's lessons to be learned by messing with things. So what I would suggest is try it and see if it works. Try it with the same number of edges on each object and see if it works. Try it with different numbers of edges on each object. Does that make sense? These are the things that we're trying to put together, the dots we're connecting, as it were. But yeah, try it. I always recommend mess with it. What's the worst that's going to happen? All right. So that in mind, lots of fun stuff going on there. Let's talk about the next skill check, which I know you guys are excited about. Our next skill check, please use either the combine tool, the bridge tool, or Boolean's operations of your choice, and create a snowman or snow woman. Wide open, anything you want. Anything goes as long as it's appropriate. Make a snowman or snow woman. Nothing that would get me fired. But you have to use those tools. And what I'm looking for in terms of your snowman or snow woman is good edge flow. So regardless of the tool you use, I want to see nice edge flow. But you can use any one you want. Now, I have for you an example guide that I can show you. He's on my hard drive using my new lecture number 7. Take home. Here's my Booleans Frosty. And again, the Booleans element here, I can see how the edges of these objects connect together neatly and cleanly. You don't have to necessarily Boolean every detail in there. Obviously, my little face parts are not part of the same guy. No, you don't have to at all. But if you'd like to, you can, because you know how. I showed you last time. So I did it because it's fun, and all the cool kids do it. So you decide. I've had some really cool Olafs. I've had a couple people build him, which was pretty neat. The snow monster. Frozen seems to be popular. But you can make anything you want. The design is wide open. It can be as simple or complex as you wish, but you must use Booleans, merging the vertices using the combine tool, or use the bridge tool. Any of those are fine. Does that make sense?
Oh, yeah.
Any good? Thank you for playing. Any questions? Is anybody? Yes, go ahead. Why is the combine tool so important? In some instances, when you're trying to attach two complex shapes to each other, like say the body and the head of the ladybug, that might be something that you could accomplish much more easily utilizing two spheres than try to extrude one from the other. Does that make sense?
So I understand, but I mean like the actual combine, like example.
The combine tool is what makes it so that you can merge the vertices. It makes it so that you can use the bridge tool. You know what I mean? Like if you don't combine that geometry, those tools won't work.
So like if I want to like find this here, so you
Booleans would also work.
yeah.
You'll notice that these three tools have similarities to them. Does that make sense in terms of how they work? So that's why I grouped them together, so that you can see how they work and how they are similar to each other, because they have similar rules in terms of how they function. Combining, bridging. Because you can't merge the vertices of two different objects. You have to combine them or they will not attach. Yep. Good, everybody? Okay. So that's your skill check. Make sure you've got that for me. With what's left of class time, I want to walk around and see your zombie kill bus, because we colored that bad boy up, and I want to see how you did colorizing the zombie kill bus. I want to see what you guys came up with, because that's a pretty cool assignment. I like that one. All right. And while we're here, I thought I'd just take a second and show you, in terms of week 3, things that we're looking for. Week 3, obviously, we're getting into some more complex objects. There's more detail there in terms of what we're asking for, and a lot more smooth curvature. So week 3, one of the things that we're looking for is the idea of having that, representing that curvature on there and creating those nice smooth transitions that more accurately represent that surface, which we refer to as edge quality. And you guys know that the tool that helps you out with that is what? Which tool do I use for edge quality? Bevel tool, but we are also using cleanup. So again, in terms of things we're looking for week 3 that we were not looking for week 2, we are going to be cleaning up our geometry and making sure that things have nice, happy, four-sided faces, neat, clean edge flow. Another one of the big ticket items that we're looking at now that we didn't have previously is the idea that we are looking for edge quality, or how does the geometry transition. It's not a 90-degree angle. I'm actually representing those smooth surfaces and those transitions the way they actually look. So I'm looking for rounded corners. Okay, so the big difference for week 3, more complicated objects. I'm definitely looking for edge quality, and I'm definitely looking for clean models, because one of the things we're going to be looking for is n-gons. So again, four-sided is the goal. Triangles here and there is totally fine. N-gons are not acceptable. So you've got to fix that with the Multica tool.
Okay, sometimes you get, when you extrude, you get weird shader errors.
Mm-hmm.
Like,